Hello everyone, let's talk about trigonometric substitution today. So right here, I have an example on one that's going to be substituted by 1 minus sine squared of theta. We have three different cases in the trigonometric substitutions. We'll have one where we replace with a cosine squared of theta, one with a secant squared of theta, or a tangent squared of theta. In this video today, we're going to work with the 1 minus sine squared of theta. So the argument that has to be replaced is this one right here, the 25 minus x squared. So something a little bit bothersome about this one because we don't have a 1 in the position here, which we would usually want to apply our property. But we can make that 1 appear very easily if we continue our integral. If we pull this out of the integral, we can see that the root of 25 times the root of 1 minus x squared over 25 dx is equal to our original argument, which is true. If we simplify this, we can pull out 1/5. 1 over 1 minus x squared over 25. This whole thing under the root dx. So remember, we can't just simplify the square root because you can't. These aren't multiplied between each other. This is a difference of two values. So we have to use trigonometric substitution in this case. So if we observe the formula, we can see that the b squared x squared is kind of what's going to become of the sine squared of theta. So if we really look at this closely, if we write here, trig substitution, right? We'll say that x squared over 25, so this value is equal to sine squared of theta. So that means that x squared is equal to 25 sine squared of theta. And that x is equal to 5 sine theta, right? Because we take the root on one side, we take the root on the other. Good. So as we know also in the u subs, you can't have an argument in u and you integrate with a dx. We actually need a du here. It's the same logic when we use the trigonometric substitution. We need a d theta as well. Very easy to make it appear. If we take the derivative of x, we get a dx. And then we can take the derivative of this side as well. So we have 5 cosine of theta d theta. So now we have all kind of the chunks to put our integral back together under the theta argument now. So we'll have 1/5, which we had previously, integral of 1 over the root of 1 minus 25 sine squared of theta over 25. So these two things knock out like that. Whoops, sorry about that. Yeah, sorry. 25 sine squared of theta over 25 like that. And then we have 5 cosine theta d theta, right? We have another constant here, which is going to simplify with the one over here, leaving us with the integral of cosine theta over the root of 1 minus sine squared theta d theta. Now we know we have the property that sine squared theta plus cosine squared theta is equal to 1, and that cosine squared of theta is equal to 1 minus sine squared of theta. So this is the same thing that we have under our root here. And that's the whole point of the trigonometric substitution, to replace it to something that's very easy to take the root of. So we'll just have over here cosine theta over the square root of cosine squared of theta. And obviously you can just skip this step if you see it quickly. I'm just explaining it so we really take it step by step. which gives us cosine theta over cosine theta d theta, which gives us the integral of d theta, and the integral of just d theta is theta plus c. Right? Like we said in the u subs, you can't just leave your argument as a theta plus c, because originally we were given a integral with x's, and we integrate with respect to x, which means that in the end we have to find a way to re-put this back into x. But we do know something. We have a little bit of a clue here. If we look right here at this line here, we have x is equal to 5 sine of theta. So let's take this. X is equal to 5 sine of theta. To find the theta right here, what do you think we should do? We can simply maybe start by putting the 5 on the other side. And to separate a theta from a sine, we take the opposite, the arc sine. So the arc sine of x over 5 is equal to theta, which means that this integral is equal to arc sine of x over 5 plus c. So that's your answer for this one. Okay, cool. Let's try another one now. All right. So the next one we're going to try, so b, we have the I is equal to the integral of x cubed over 9 minus x squared dx. Guess this one's a little bit more tricky, but it's still under the same form, a squared minus b squared x squared, which is similar to 1 minus sine squared of theta, which is equal to cosine squared of theta. So we're still dealing with the same case right here. However, we have also this x to the 3 on top, which seems to be a little bit bothersome. But we'll see eventually it's not that hard to deal with. So if we take a trig sub right here, let's do a trig sub. We try to do it in one step without putting it on a fractional like we did in the first one over here, right, where we pulled the 1/5 out. Let's try doing this in one step. Let's say that x squared is just equal to 9 sine squared of theta, right? And that x is just equal to 3 sine of theta. Like we said before, you can't just have a dx and use theta at the same time, so we need to find d theta. So if we find d theta, we just need to find dx. So we derive x, so dx is equal to 3 cosine theta d theta. Good. Thing is though now is that we have the little x to the 3 on top. That's a little bit bothersome, but we have x right here. So to find x to the 3, we just take it to the 3rd power. So we say, well, x to the 3 is also 3 times the argument here. So raised to the 3 argument of this right here, which means that x to the 3 is equal to 27 sine cubed of theta. So if we put all our chunks back together, on top we have an x to the 3, so this becomes 27 sine cubed of theta. On the bottom we had the root of 9 minus x squared, so 9 minus 9 sine squared of theta, right, because x squared was equal to 9 sine squared of theta. And then this is multiplied by 3 cosine theta d theta. So let's start with the first step. Let's pull all our constants out. Well, we know that if we pull a 9 out of our root, and we do the root of 9, that gives us 3. And we have a 3 up top, so that's going to cancel out. So only thing that's going to be left with is the 27 up here, which means that we'll have 27 integral of sine cubed of theta over 1 minus sine squared theta times cosine theta d theta. If you see it right away, we know that this will become cosine squared of theta, and then we take a root of cosine squared of theta, just cosine. So these two big chunks can simplify right off the bat. Good. So we'll have 27 sine cubed of theta d theta. Once we get to this step, we have two options. What we can do, we have a reduction formula for our sine cubed. If your teacher will give you that in your exam, that's great, but a lot of teachers don't actually give the reduction formula. So you can do it using a u sub. So what you need to do in a u sub, in this case, is that you need to pull out a copy of the sine. So we'll have 27. I'm just going to rewrite this here. I'm going to rewrite the same step so we can go to the next page. Good. Sine cubed of theta could also be written as 27 sine squared of theta times sine theta d theta, which is allowed. All I did was pull a copy out right here. And then we know with our formula that sine squared of theta is equal to 1 minus cosine squared of theta. Okay, so we have 27 integral of 1 minus cosine squared of theta times sine of theta d theta. Now simply, we know that with the trigonometric substitution here, we can place u as being equal to cosine of theta. And if we take the differential of u, so du is equal to minus sine of theta d theta. What this allows is it already removes a copy of the sine, simplifying the problem for us, which means that our integral will just now be equal to negative 27 integral of 1 minus u squared. And we put a bracket right here, remember, because we're applying the du to both of these things. With the property of the integral, we can separate the integral into two pieces. So minus 27 integral of du minus the integral of u squared du, which is just equal to minus 27 u plus 27 u cubed over 3 plus c. Good. So we can simplify a little bit more here. We say minus 27 cosine of theta, because u is equal to cosine, plus 9 cosine cubed of theta. Good. Now remember, we have our thetas, and we can't leave it under theta form. We were originally given x's, and we know that we had the property x is equal to 3 sine of theta. So this one's a little bit more tricky than the other one, because you have to really think about this for a sec. X is equal to 3 sine of theta, mean that x over 3 is equal to sine of theta. If we were to draw a triangle right here, a right triangle, right, it's not perfect, but we have a right angle here, and we have our angle theta, like that. If you ever heard of the acronym, which I think most of you have, SOHCAHTOA, the acronym right here stipulates that sine is just the opposing side over the hypotenuse. So if we look at the angle of sine, the opposing is x, it's on the numerator, and the hypotenuse is 3. And with Pythagoras, we can know that h squared, so the opposing, is just equal to, so hypotenuse squared is equal to the opposing side squared plus the adjacent side squared, meaning that the adjacent side is equal to the hypotenuse squared minus the opposing side squared, the root of that, meaning that the adjacent side here is equal to 9, so 3 squared, minus x squared under a root, like that. So what's this useful for? Well, when we look at the cosine right here, the cosine is defined by, so the cosine of theta is the adjacent side over the hypotenuse, right? Meaning that for a cosine argument right here, will be given as the root of 9 minus x squared over 3. Good. So what happens here is that we'll have something back in our integral. We'll have minus 27 times cosine of theta, which is just now the root of 9 minus x squared over 3, plus 9 times, remember we have a 2 to the 3 here, 9 minus x squared over 3, this whole thing 2 to the 3 plus c. And I apologize here, I forgot my c. If we develop a little bit more, clean this up, we'll just get minus 9 root of 9 minus x squared plus, and then here I believe your teacher will let you, but kind of up to them, we'll get 9 over 27 times 1 over 1/2, because it's the root, times 3, so we'll get 7/2, but I believe you can just leave it this way. I would just leave the argument as that. We'll have 1 over 3, so 9 minus x squared, this whole thing to the 3 over 3 plus c. Over 3, because 3 to the 3 is 27. 9 divided by 27 is 3. So this would be your final answer to the second integral. So typically when you have these type of questions, you'll always have to resort back to using the triangle, because the triangle can really help you establish what side is what thing is which makes it very easy. This is one of the trickier chapters you'll have in an integral calculus class, so once you get these examples down pat and you really become quick at them, they become very, very easy over time. So that's really the thing to remember, and remember this property right here, SOHCAHTOA, very important to solve these problems. So I hope this video was insightful to you, and I hope you enjoyed it, and I hope you have a nice day. Bye.